Welcome to our series on mastering higher level algebra. In this particular video, you are going to understand how do we solve problems related to telescoping series. We'll get to the basics, get our foundations right so that problems which you see here can be solved in less than a minute. Let's enjoy this journey of learning. Thank you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll look into telescoping series. Now, there are many videos in the playlist for you to explore and understand the concepts. It is kind of important to understand this beautiful concept as it helps at working out good questions based on higher level algebra. Also, in sequences and series and partial factorization, we have similar examples. Now, in this video, we'll discuss what is the sum of these terms, which is 1 over r times r plus 1, where r changes from 1 to n. While describing the solution, we'll go through these steps. First, we will understand how do we expand a sequence using sigma notation, as that could be new for some of our students. Then we'll write each term as difference of two terms. So you get an idea. Let's say if you have 2 minus 3 plus 3 minus 4, like that. Now that is kind of a difficult step, so it involves critical thinking. And that's the key to find solution to such problems. We'll introduce you to some beautiful techniques to do this at ease. Then we're going to simplify the series, which is not difficult since most of the terms in between get cancelled. Normally, you land up with the first and the last term. So, with that, we'll also develop a formula so that if a question comes like this in examination, then you can answer that question in less than a minute. Exciting, right? So now let's look into how do we work with this. So let's begin by expanding the formula itself. So as you see here, sigma notation basically means sum of terms, right? So you have to put r as 1 to begin with. So if I put r as 1, I get 1 over 1 time 1 plus 1, correct? Plus. So this is sum of sequence which is for different values of r. So now we'll put r as 2. So we get 1. And if I put 2, then it is 2 times 2 plus 1. So what do you see? This is a general term, right? So normally we also write general term t r, you can write, since we are using r, as equal to 1 over r times r plus 1, right? So that is the general term. You'll use concept of general term in solving many sequences which involve binomial theorem also. Okay, let's continue here. So we have now r equals to 3. So that gives us 1 over 3 times 3 plus 1, right? Plus so on. And well, the last term will definitely be 1 over n times n plus 1. Now let's see what do we have. So we have 1 over 1 times 2 plus 1 over 2 times 3. You see that? So 1 over 3 times 4. So we have product of consecutive terms in the denominator. You get the idea, right? So 1 over n times n plus 1. Perfect. Now from here, how can I break this up into sum and product. So that's a great technique. So we also call it partial factorization. So I can actually show you with the general term how do we break it up into two different terms as sum and difference, right? So let me show you right here. You see, we have the general term as 1 over r plus 1. So I could write this 1 as what? I could write this as r plus 1, right? Okay. But we need only 1 on the top, so minus r makes sense. Over r times r plus 1. Do you see this concept? So what I did is that I wrote 1 in the numerator as r plus 1 minus r. Does that help you a bit? I think it does, right? So let's see how it helps here, right? So what I'm trying to say here is that instead of this 1, r over here is 2 for us. Do you see that? 2, right? And in the next term, r is like this is 1, this is 2, this is 3. You see the value of r. You see that? So, how do I split it? This is what I'm trying to teach you. So, we could write r plus 1 over r. You get the idea, right? So, see, I'll show you here. So, I could write this 1 as 2 minus 1. Do you see that? Over 1 times 2. Makes sense. Now, here, I could write this 1 as 3 minus 2. Do you see the difference of these two? Do you see that? And then in the denominator, I have 2 times 3. Plus, here I can write this as 4 minus 3 over 3 times 4 plus so on. And here, of course, I could write this as n plus 1 minus n over n times n plus 1. Makes sense? You see, now we have terms which are add minus subtraction. Do you see that? Now, let me take it on a new page to really show you how we worked with this, right? So, some of you can actually now write down the solution also, right? Okay, right, great. So, what we came up with is this we could write this as when I put it 1, I get 1 times 2, you get the idea, and we wrote the numerator as 2 minus 1, correct? And when I substituted 2 here, in that case, it was 2 times, well, this was plus in between, right? 2 times 3. And we wrote 3 minus 2 plus this was 3 times 4. And we wrote 4 minus 3 plus so on. And we wrote this as n plus 1 minus n over n times n plus 1. Perfect. Now, do you see the technique? We could now write this as 2 over 1 times 2, right? 1 times 2, right? Minus 1 over 1 times 2. Makes sense, right? Similarly, the other term I could write as 2 over 2 times 3 minus 2 over 3 over and then minus 2 over 2 times 3. Makes sense? Plus 4 over 3 times 4 minus 3 over 3 times 4 plus n plus 1 over n times n plus 1 minus n over n times n plus 1. Do you see that? Now, here we have terms which are positive, negative, positive, negative. So do you see what is happening here? Let's rewrite this, simplify. So this is 2 over what? 1 times 2. So I could write just as 1 here, right? Correct. Minus. Now here this is half, correct? Plus. Now what is this? So 3 and 3 cancel, as you can see. You get half here minus 2 and 2 cancel minus 1 over 3. Do you see that? Plus here 4 and 4 cancel. You get 1 over 3 minus 3 and 3 cancel 1 over 4. Do you see that? So likewise, this series extends, right? And what we have here is n plus 1 cancel, 1 over n minus n and n cancel. So we get 1 over n plus 1. Do you see that? So as you can see, we have sum of numbers which are plus minus plus minus plus minus. So that is the critical thinking step which I was talking about. So the idea is to really look into how do we split this term into two different terms so that one is positive, the other one is negative. Once you do that, now it is simple. Minus 2 half cancel, right? Minus half plus half. Minus 1 by 3 plus cancel, this cancel. Do you see that? So, what really happens is that only terms left is the first and the last term. So, we get our formula, and which is definitely equals to 1 minus 1 over n plus 1. Do you see that? So now we have a formula. So we can now write down this sum of the series, which is for r equals to 1 to n, for any series which is 1 over product of consecutive numbers, right? R times r plus 1 is definitely equal to 1 minus 1 over n plus 1. Make sense? Now, here is another important variation to this. Sometimes we are looking into infinite series. Infinite series means when n is approaching infinity. Now, if n is approaching infinity, then 1 over n plus 1 will approach what? When you divide by a very large number, it is going to approach 0. You see that? So, we have a formula for that also. You see that? Right? So, let's now understand what is the formula when we do this expansion uh, for r equals to 1 to infinity, right? For 1 over r times r plus 1. So that'll be 1 minus 0, right? So which will be 1, right? So basically that will be just 1. The sum of this series will be 1 if n is extremely large. So in any case, the sum approaches 1. Perfect. So I hope you have understood this concept. Now, based on this concept, we have a very beautiful question for you to attempt. So, so here is the question. We have exactly the same series, and I've also provided you with the formula here, right? So, general formula is when r goes from 1 to n, in that case, the sum of the series can be written as 1 minus 1 over n plus r. You see, the general term which we had here has been factored partially. This is what we call partial factorization, and that is the step which we showed you how to get to this step by splitting the numbers, right? 4 minus 3, 5 minus 4, and so on. We get this particular formula. And we also learned just now that the sum of infinite series, when r approaches infinity, right? For this sum of series, which is 1 over product of consecutive terms, right? Remember this part, will be equal to 1. Is that clear, right? So this is, we have 1 over product of consecutive terms. So now if you see the series, in that case, you know what the answer should be, right? So that is. Now here we have a variation to the same, and this is your test question. So I like you to now pause the video, answer this question, right? So we have, based on what we have learned just now, a test question for you. So try to solve this, substitute, you can substitute this in the formula also directly, and then work it out. Feel free to share your solution with us. In case you really need help, you may always send an email on globalmathinstitute@gmail.com. Our students are right there on the top. Thanks for your valuable time and suggestions. Thank you. All the best.